Yeah, okay. Everything works fine as far as audio. Sweet. Let's also start this. Boom. And yeah, let's put it over there. Oh, that is good. And now let's look at y'all's reading. Sweet. Just about everybody. That's nice. Sweet. Okay. All right. All right. Let's start with the reading assignments. Which you guys did a great job with. You guys right on the set. So let's start there and build into what we're doing today. So the first question on the reading assignments, ask you guys. This, I said A times B equals 0, and I kind of asked you, so if I have two things that multiply to give me 0, what has to be true about one variable? And what did y'all tell me? It have to be 0. Say it again. Be 0. Yeah, they have to be 0. So that's what I said. You guys are exactly right. So why does that make sense that one of them has to be 0?
Let's say you put like, let's say A equals 1 and equals 2, well, that's gonna be 3, and it's not true to the
So if we put two non-zero numbers there, we just kind of know from trial and error in our head that if I multiply two things that are not zero together, I'm never gonna get 0. But if at least one of them is 0, then it's kind of the reverse. It always goes to 0, right? As long as you got a 0 in there and it's multiplying, it's like a black hole. It automatically makes it. Okay, good. So at least one of these has to be 0. So then the second question was, I gave you this, so now my two things being multiplied are this, x minus 6 times x plus 2. That's what I wrote. So if these two are multiplied and it gives me 0, what has to be true about the word? Yeah, so let's kind of look at this. Surprising thing was, let's look at, it's a really good question. So one, I think, logical possibility is x itself. Let's check that out. So if I plug in 0 for x, let's see what we get. What's 0 minus 6? Yes. And what's 0 plus 2? 2. And then what do you get when you do negatives? So, but this is really important to look at. It's not necessarily that x has to be 0. Because honestly, so what happens is the minus plus things just kind of make these number terms. It's not necessarily bad. But again, on the first one, I kind of asked you A times B equals, so thing 1 times thing 2 equals 0. You know, one of those things has to be 0. This is thing 1 and thing 2. So no matter how complicated these parentheses look, this is just one thing times another that equals 0. Apple times orange. So what has to be true about one of these things? And figure over. Figure you're looking for a solution instead of just yeah, yeah. So what did you guys say? So I just looked at the reading assignment. 17 of y'all did the reading assignment. You all said the right answer. So like, don't overthink this. Don't look for the right answer. Just tell me what you think. Say it again. Yeah. So one or both of these has to equal 0. So either x minus 6 has to equal 0, has to be 0, or x plus 2 equals. So that's the first part of the second question. That's all I was looking for, was just to continue that same idea. Okay. don't overthink things. Don't always try to get to the solution. Because oftentimes in trying to get to the solution, you just make a small error getting there. So we'll let things be step by step. But so I know that one thing times another equals 0 means one of those things, either x minus 6 or x plus 2 equals 0. And then my second part of the question is, what is x time? So then it would be, when you solve these. What it is. Yeah, 6 and 52, and how do you get the 6? How do you see?
Like you add 6.
Yeah, we got that 6. And 6 over there, so we get x equals 6. And this try 2 here. Right next to this. Sort of that familiar. Alright, so you guys have the right idea. The question then is why, I give you this reading assignment, why am I setting in this particular set? That's what it says sometimes, zero, and why you introduce that. So that's where I want to get to, sort of not just today, but sort of the rest of this week. So the rest of this week, we're going to talk about equation solving. We've done equation solving in this class, so we've just used it. But there's a type of equation solving that you're going to see in this class that is, I won't say different, but it's sort of, there's an extra step or an extra thing you need to do that's different than the equation solving that you saw in whatever math you did. So I sort of introduced this to you, you're kind of going to see this in this over. I introduced this to you because this will help us with this type of thing. So this new type of equation solving will help us solve stuff like the following. So I want to give you guys a problem. So this is again not, we'll see plenty of other things that don't look exactly like this, but this is a good place to start. So what we want to look at this week is solving something. Let's see. Well, I'll start with I want to give you guys an equation that I at least know that you guys know how to solve. So I'm gonna give you something that we've stumbled across solving in this class. Let's help a little room here. So what we've done in this class so far is maybe solve something like the following. Maybe 3x plus 4 equals 8 something like this. And how would you solve something like 3x plus 2x? Subtract 4. And then that's good, but somebody else give me the next step then. So what would you do from here? Divide by 3, perfect. So this equation solving that we've done so far has just been trying to get x bites. But in this case, that's. But you just eliminate things. You get rid of things by doing the opposite operation. And at least for me on first blush looking at this, you should be able to do that. How many of you guys, let me also kind of see where you guys want to go. How many of you guys remember solving this in your previous math class? So just a couple. Okay, so that's good. So the thing is, if you already know how to solve this, then please don't do the next thing I'm gonna ask you to do. But we just have a couple of people, so it's not big. I'd actually, it's good. I've heard you guys are kind of fresh on this. For the rest of you all, though, what I want you to do really quick, the first thing we're gonna do is I want you to try to solve this like you know how to have equations. And I'm gonna guarantee you that you're gonna run into a problem with it. But this is a good exercise, so I want you to try to solve it that way. When you run into the problem in your mind, just kind of like give a description of the problem. Categorize the problem. So when I come back, I'll give you guys a couple minutes to do. When I come back, I'm not gonna ask for the solution, I'm gonna ask for what problem you ran into. But so take a couple minutes and try to solve this the normal way.
We will be there.
What we just talked. So no, it's there. So sometimes like, well, don't too far ahead. What I use more than time is intuition, so this tendencies into them. Like, not trying to show. So there's a lot of good in doing this the wrong ways and figuring out why it's so nice. I think I really do swing and talk about this.
The way.
Yeah. Yeah, so that's a little bit, so when I ask what's. What possibly run to, that's.
What's it way?
Okay. Alright, so let's see, let's see what you guys got, let's see if I can also deprogram it. You guys have been way too programmed to like do the right thing all the time to get the right answer. And I know that sounds weird for math teachers, but oftentimes you learn more from doing the wrong thing, and then the key is figuring out why it's wrong. It's not that it's wrong. F that it's wrong, whatever, wrong, right. Why is the wrong thing the wrong thing? Why doesn't it work? Because that tells you a lot then about what the right thing is and why it is. So I will slowly deprogram you guys. So, uh, so if you try to solve this the normal way, take me through your first couple steps. What did you try to do? Subtract 8. So normally we would subtract 8. X squared minus 6x is -8, and then make the square root of x squared. So you probably see 8 used to get x by itself. Now, the one thing with this, if you're gonna take the square root of x squared, because of the subtraction, these are kind of stuck together, so you really have to sort of try to work on one basis. So you can't do just one. If this was x squared equals -8, yes, you can do that. And we'll look at some problems later, but But that is one problem that we run into. So, like I said, my question was not gonna be, what's the right answer to this? Because this method is not gonna get us there. The question is, why doesn't this method get us there? So what problem do you run into? And if you took this approach sheet, the first problem that you run into is I can't take the square root. Normally we do, we take the square root to get rid of a square. Can't do that here because of the -6x. That's one problem we run into. Now if I could somehow, well, so somebody else give me, did anybody else do a different step here? Or somebody else just describe to me, what's the problem we're running into? So it's not, it actually isn't that we can't take the square root, but. Yeah. So normally when we're solving equations like this, even if I had another x, like if I put a 5x on this side, the powers match, they're like terms. And the nice thing about like terms is how, once I start moving, say, the 3x over to this side, I would be able to combine like terms. And we'd end up with only one x, physically only one object that is x. Problem here is they're not like terms. So actually from here on out, no matter what correct move you choose, the problem is I'm never going to be able to combine these into one term. So they're not like term, which means I'm never going to be able to do any of the stuff I normally do to solve from there. I won't be able to divide, I won't be able to take square root. I just won't be able to do it. So that's kind of the interesting thing. So you get an equation like this, it just structure, like the way it's structured, you don't have like terms. And as soon as you don't have like terms, you can't start the equation solving this way, unfortunately. So then the question is, if I can't do what I know how to do, the equation solving that I know, how do I start this? Here. So, and this is why I kind of showed you guys this second question of these. So it ends up then your alternative, so about half the equation you're ever going to see being solved like this, because you have like term. When you don't have like terms, that's the other half of the equations that you're going to see. You have to start almost, not always, but, and we'll look at some examples where you do something else, but other approaches, you start like that. So this little form that I wrote for you is not, you don't always see it exactly that way, but that's basically factor. That's when you factor. Do you guys remember factoring stuff like this in your previous class? And if you don't, please tell me that, because I need to know where you guys are so I know how deep we go into the factoring here. But yes, yes, and yes, okay. No, that's good. I mean, you guys actually might have a better preparation, better play here. All right, so if I'm gonna factor this, so in the previous class, they should have taught you 3 types of factoring. And the first type was looking for a common factor. And do you guys see a common factor there? The factors. So a 2 does divide into 6 and the 8 doesn't divide into the 1 here though. So close, but we need something that divides into all 3. Yes. Yeah.
And to early changes that hours and
Yeah. Yes.
Okay.
So we'll get there. So, but again, I don't want to just jump to the right answer. So.
Divided by
Say it again.
1.
Yeah, so the best you can do as far as the common factor is 1. So this one can't be, doesn't have a common factor. So when you're, let me move this camera, let me write this over here. When you're factoring, so I want to write this up here as just a very weird brief summary of factoring. But just of the methods that were in that you guys got taught that we use. Help us kind of go through these problems. So the first method, they call it greatest common factor. And if it wasn't told to you in your previous class, you should always look for a greatest common factor first. So these methods of factoring, you want to think about them not as what is the right way, but these are 3 tools on your toolbox. And when you work these problems, actually, some of these problems are going to use 2 methods. So you got to be able to look at it and figure out, is my tool useful on this problem? Not which is the right tool, which tools are useful. And so the first thing you should always look for, honestly, is greatest common factor. So again, not right, but not half the problems you're going to look at actually you can factor out. And so it's on a problem that you can factor out a common factor, it's useful because it makes the rest of the work lines to factor out to do that for you. But like on this one, if you don't have a common factor, then I'm not gonna give a name, but there was this method where you'd end up breaking it down into two parts. And this is often useful, it's useful most of the time when you see 3p6 and you see a square. It's a highest power. 3p6 is a square and highest power. Then not all the time, but most of the time you can factor it, which is perfect. And at factoring into 2 parentheses, this is where I want to see how much of that you guys remember. So I know you guys are in the class I just taught before this, they didn't remember any of that. So we have to do a lot more of this. But you guys I know remember the factoring. So something like this, we should be able to break this into 2 parentheses. And I want to see how well you can skip that. So take a couple of minutes and see if you can factor this. If you can't, that's fine.
Super.
That wouldn't, but also the insights are rare. And you need to.
Zero.
Yeah.
That's how we do. It's all right.
Oh, yeah, that's, and all I should mention, that is the easiest machine, usually. So that's. Alright.
She's only been ingredients.
Yeah. Yeah, you might be so used to it. All of you still on pushing.
It doesn't rain.
Then on this one, this is clear. Yeah, very useful. Really big different, there's 3 different tools for battery. You can skip seats. Yeah. Yeah. Oh, I see. Well, greatest on the back, we'll go over special order basically. We're going to solve these equations by doing that. Yeah, that is.
I'm scared.
There'll be other talks too.
You.
All right, let's see what y'all are doing. Right, so. Did anybody get? Sports 4. How many of you guys, so I'm not expecting everybody to, how many of you guys got those factors, x minus 2 times x minus 4? How many of you didn't get any factors? Kind of didn't know how to do that, like you knew that this is what you needed to do, but you did not. Yes. What about the rest of y'all? Please give me information, like. Yeah. And.
I guess. Wow.
I think
I got nothing.
you got nothing. All right, let's see, so I have a couple people that were able to go, so how did you get, so now I'm more interested in that, not right answer, how did you get this? They didn't base to do that in there, they thought it was fun. Or did you, did that ring fell or?
I don't know.
Okay, and you said that this is the day, I'm where, you know.
Oh.
So, even that way, since most people don't remember the fact that they're gonna have this, the teacher. Sliding and see if you like it, but we've done. And then say that you were talking about the method we had, what they call it was last semester. Oh,
Yeah.
you did remember the boss. Okay, so again, mine's gonna look different, it does the same thing, so the whole thing about all these methods on this factor is. They literally all do the same thing, they just rearrange the picture. They want to push the, so if that worked for you, keep doing it, but I'm just gonna give you a different picture. Since most of you don't remember how to go from, I don't remember. Then I'm gonna teach you guys my version of this factoring, which is called the CAT method. And I think you guys are gonna see why once we get through it. I sort of invented this method. Again, all the methods are really the same thing. It's the same piece, but they just rearrange it differently. I invented this method because I'm a very visual person, and I also know that, like, in general, people are a lot more visual now than we were like before. And so I invented this method just because I was like, I can make a picture out of this. And actually, for me, it makes working through the pieces much clearer because it becomes a puzzle note rather than a bunch of algebra. So here's the puzzle. Here's how we figure this out. So what you're doing, whatever type of factoring we're doing, what you're always doing with factoring is you're doing reverse distribution. So when you multiply 2 parentheses here, you know that whatever's in front here, you multiply by both pieces here, and then you multiply the next piece by both, and you combine like terms and you do all that. And so what I'm going to do visually is I'm just going to reverse engineer. So the first thing you need to know is the front, sorry. So the front times the front gives you the front. So these two pieces, when you multiply them, give you x squared. So then you just gotta ask yourself, what times what gives you x? Yeah, so X, does that make sense to everybody? X times X gives you X. So again, this is a puzzle. Which all good mathematics is puzzles. We've made it a bunch of algebra and probably left to right, but honestly, mathematics is puzzles. And in like primary school and in a lot of other countries, and when I say a lot of other countries, I mean a lot of other countries. It's only in America and Europe that in elementary school, when you're learning math, it's all of this stuff written on paper. In a lot of other countries, they actually teach math by giving people games and puzzles. It's not the only thing to do. So have you guys ever played that game Mancala by any chance? So Mancala actually comes from, I forget which West African tribe it comes from, but it's used pretty much in a lot in Western and Central Africa. If you think about playing Mancala, you have to do addition and subtraction really quick to figure out your goals and to figure out the right moves, right? So I'm saying this quite literally, they use Mancala to teach addition and subtraction, like first, second grade in West Africa. Because it's a lot better than Taco. It was a lot better than it. So it's only in America and Europe that we could teach math that way. So anyway, so I'm saying all that to say, when you make math into a puzzle, you'll find that honestly, a lot of times it's actually. So here's the puzzle. So X times X gives you X squared. So the fronts give you the front. And then the backs give you the back. So when I need two things that when I multiply them, I get 8. So 2 and 4. Now notice it's. No, but you're trying to go right. So one is the right. So 2 and 4 is one option. But there's actually another option. 1 and 8. 1 and 8. And also you got to think about positives and negatives because positive 2 and positive 4 works, but so does negative 2 times negative. So does negative 1 times negative 8. So there's actually 4 possibilities right now. The inevitable part of this game, all this factoring that you guys have been doing, they've been studying this for about 700 years at this point. It's still trial and error. So there's an inevitable part versus trial. You have to be okay with making a choice, getting wrong, and then erasing your choices and going back and making a different choice. And that is legit mathematics. So we need to choose one of those possibilities and go with it, see if we get a middle term. So what do you guys want to do? Okay, let's try 1 and 8. So let's try 1 and 8. Do you want it to be positive 1, positive 8, or negative 1, negative 8? Well, if we do negative 1, positive, let's check that. When you do negative times a positive, what do you get? Negative. So we can't have both of these. We can't have these can be different signs. But maybe let's do negative 8. Negative 1, negative 8. So those two, when you multiply them, you do get positive 8. So that's give me the back. But notice that what I have so far is only half of the distribution that you would do. So if I asked you to multiply these, you would do X times X, which we've already done, but you'd also do X times negative 8. And you would have also done negative 1 times X, which we haven't done yet. Negative 1 times negative. So let's do the parts that we've missed. What's negative 1 times X? What's 8? X times negative 8? Yeah. Guys, don't be afraid of your answers. You already know how to do this. So you guys know how to do distribution. You've shown me that in the last 5 weeks. So I don't know. Maybe you guys just don't like to talk or to answer a lot of questions. But have some fun, guys. All right, so we've done all the parts of the distribution, X times X, X times negative 8, etc. If I asked you to multiply these, you would multiply all the pieces through and then you combine like terms. So let's combine like terms. What's negative X minus 8x? Negative 9x. So here's the puzzle part of that. Does that match the? So all that means is out of the 4 possibilities that we have, this one doesn't work. So our job is to find the right one. So it's not negative 1 and negative 8. Let's try -4 and -2. And if we do that, then what's -4 times x? -4x. What's x times -2? -2x. And what's -4x minus 2x? -6x, and then you got it. That matches the. Fronts give you front, backs give you back, and then once you've matched the middle, then you've got the factoring correct. So this is a way to do this factoring that, so see if you like it better than taught before. You don't remember what you've been taught before, I'd say honestly, as long as this makes sense to you, go with this, because this is a lot easier. This is the other methods they teach. This it's all picture that you work on in your head. So you'll see very quickly that your head will start to work out this picture you'll install. So what we have now is x minus 4 times x minus 2 equals 0. That's the correct factoring. Now, once we have that, we want to get back to my goal is actually to solve. But the reason that I'm factoring, so I think the next question is why the hell did I have you guys factor? Notice now this looks like that second problem I gave you guys in the readings. And so now I can solve for your equations. We got one thing times another equals 0. So what do I know about each of these?
0.
That one or both have to equal 0. So I just write down what I said. So either x minus 4 equals 0, or x minus 2 equals 0. And then I can solve both of those. So what would you get when you solve it?
1.
Add 4 to both sides on this one. X equals 4. And then what else? Positive this one. Add 2 to both sides there. So x equals 2. And do some. When I was kind of walking around, people were asking questions, Jay pointed out back there. Hopefully this kind of strikes you as either awesome or weird. That everything else that we've solved before this, when you solve it, you have one answer. Notice all the equations we solved before this, the power of the x was a 1. But immediately, once the power is 2, we get 2 answers. And we'll see you don't always get 2 answers with power of 2, but you can have up to 2 answers. So as soon as you start increasing this power, we're actually going to start increasing the number of answers that you naturally get to these points. So for an x squared, like I said, not always, but more often than not, naturally you should get 2 answers. And if this was a cubed, more often than not, naturally you should get 3 answers. So it's now going to be very normal for you to get more than 1. And that is very normal. Okay. Let me give you another one like this to practice. We won't get to it today, but the third method of factoring, by the way, so the third little tool that they taught you guys in whatever class before this is called grouping. And we will get there by the end of Thursday. But after 700 years of trying to figure out factoring methods, these are kind of the 3. There's a couple other random methods that only work occasionally for 1 or 2 different polynomials, so we never teach them because it's kind of useless to teach you something that only works 0.1% of the time. But actually, these 3 methods will cover probably 98% of factoring that you'll ever do. So that's why we teach just those three. So let's do another like. So same thing with solvents. Let's do. So. Notice, same as the last one, we don't have a common factor. So pretty much I want to get us to start practicing this cat method, the two parentheses first, and we'll go back and work on common factors. But notice it doesn't have a common factor. So you want to do the same thing as you did on trust. And I'll give you guys a little time to do that.
One back. One. One. We don't have to be. Nice.
I think that's what the.
I think I got it now.
So for the two parentheses here, what did y'all find that works? Make it positive. So let the next one, so it's x plus 3. The next times x is x squared. Those two multiplied to be negative 24. It's a negative 8x plus 3x, which is a negative 5. That's the correct factor. And then what you need to solve there.
X, well, yeah, bigger than it's eight. Plus three.
Yeah.
So for that.
Mm,
X. It was right. Six.
X plus 8. X equals negative. Good. Any questions, confusions there?
Too easier.
Yeah. All right, good. And let's do. Facet. Next one, let's try. Math. And again, no greatest common factor. But we're gonna try to break this into two parentheses. The first thing that I just want to highlight here, and maybe you already see it, if you already see it, then that's perfect. But so our fronts create the front. This time I'm not creating x squared, I'm creating 3x squared. So I need to get a coefficient in front of there too. So what would you have in front here? 1 times 1 is mix. Say it again?
3x and just the x.
Yeah, so 3x and then just an x. 3x times x is gonna give me 3x squared. And then from there, this plays out the same. So find combinations that give you 8, then work out the. So same distance, you guys are cruising along pretty well with this, I'll give you guys a couple minutes to work that factor out. That's right. I'm going to. It was right. You're a neighbor. So, what in the movie? So then, it's gonna come away. What's that? And we said, we're for cancer. So you're going to come get as much of it. So you already some people, you need to us. They were two. It's like he was what with this 10. 2 times. So this is a blessing. So, and it's useless. We're oh, isn't that very good? So try to reach something. I wouldn't. Go ahead. But you're. So, ready? Okay, should they put this on? So for the utility back multiple language. That's very good. So use the first. What's on this? Another sort of is more simple, really just so you just think about. What's on the and there's several possibilities, 8 times 3 is what that, so it's essentially. That's what happened, you see this meeting here, I mean. You'll go ahead and choose some the other.
Well, all I got was,
So you.
all I got was these two,
6 and 4.
because like, I did like the number of those.
So we'll take this one.
So I got
This is
5,
not something.
5, that's the same. That's the 6. I just don't know how to use zeros. I just act like I got it. For me, just come on. We never come over here, so. Do you get there or not?
I feel it's just like a little
With that
figure
part.
out. Oh, I already got.
See? So
But like, it was outside of the results. You get it, right?
Come on, I did it wrong.
see on this one.
I did it wrong. I was about to tell, oh yeah, I got the bachelor's. Oh, I did it wrong. I was looking for, I was looking for 10. Oh, man.
So like, you get that.
Yeah, see, I got stuck right there. And I was like, oh, I'm clicking. But I believe you were wrong. The one thing.
That's like,
So,
oh yeah, something.
bro.
Yeah, it's crazy.
Oh, if you told me, I would have told him, like, oh, yeah, I got it.
Alright, let's go ahead and see what you're getting. Alright, so we needed two things that multiply to give me eights. We're gonna try to work that around to give us 10x. So what did you guys end up getting? And where'd you put the 4? Where'd you put the 2?
That's great.
It's like,
So again, I'm actually hoping that you probably didn't, maybe you guessed it right the first time, but you're like, probably didn't. And so that's what should be the result of most of the time. You gotta get used to with this. Most of the time, you may not guess the right the first time. So that's fine. Erase it, guess again. This is the final arrangement that should have worked for you. So 4 times 2 is 8. And then in the middle, I get 4x here, 6x here, and 4x plus 6x is 10, which is exactly what they're. And then once we have that, let's go to. So each of these equals 0. And then somebody take me through and solve.
I was trying to.
Yes, you got it, subtract 4, then dividing by 3. So this one, you're not gonna be able to see the answer like you can something like x plus 2. But you just go and solve it. And fractions are friends, their answer is just as good as numbers. So one of our answers is -4/3. Let's see. Yeah, got 2 from both sides. And we get x equals -2.
you mentioned like slide over to 3, like 8,
You divide.
and like you just, have you ever heard of that method?
Yeah, so this is one of, if you're using that method, go ahead and use it. So in my classes, I teach this method because for my classes, I found 80% of the students like this better than that method. So I'm not saying, but if that method works for you, use that. Don't use one. But for most people that I've taught, they like this better. And that is, again, a really important point that, and we're just getting to the level of mathematics where there's usually a couple different methods that do the same thing for you. And one thing that you should always do as a learner, as somebody who's trying to figure stuff out, is find the method that works well for you and run that. So you're no longer at a point where as a teacher, I can tell you this is the one method, you shouldn't do anything, that just doesn't work, that doesn't make any sense for anything. So if you come across that, something like this, and you have another on it, you're gonna get the same answer that I'm gonna get. Do what works well for your. Same with mental. Do what works well for you. All right, I think, let me see how much time we have left, where I wanna go with this. Let's do a couple more problems, again, using this method and so on. When we come back on Thursday, I'll kind of show you some problem work. Let's stick on this for now. So I guess we're at. You. We'll put it something like this. Lord squared plus 3x equals. And what's kind of the difference in this equation compared to all the ones we've done previously? It's not that. It's not that. Yeah. So what can we do to kind of remedy that? Yeah, we can just kind of subtract that. So we could divide, but it ends up being. So one of the ways, so this is a strategy, obviously, this is a gaming strategy, it's not a math strategy. So if you're ever playing a game and you encounter some new scenario that's just a little different than the older scenario, right? Then usually the best strategy to start with is just make it look like the old thing. Because you know how to solve the old thing. So as long as you have one move that gets you back to the old setup, then the most efficient thing is do that one move and then do the old thing instead of trying things. And so that's essentially what we're gonna do here as well. I could just subtract 10 and then I do have my zero. And again, that's quick, that's easy, and more importantly, it gets it to look like what I already know. So then what's the left side? How's the left side gonna read? And then equals 0. Right. And then we can solve from there. And that should work out well, so, I know, go ahead, same deal, take a couple minutes and work through factoring that and so.
No. How much is legs so still? What is it? That's not very good society.
Yeah, well, like how. Actually, that's the reason that, let me just figure out this. Well, this is,
Oh, okay.
yeah. Yeah, it's pretty much, so if you're doing line, then you're just checking. So -5 times 2 is -10, 2 times 2 is 4.
Yeah.
That's what you get -6, which just doesn't. So then if you try the 4x to the x, this actually does 40. So that's negative, so -5x plus 8x, so gives you 3x, yeah. Yeah, whenever you check the, so yeah, that, when you check it, you do that. And that's what I call the middle parts of the distribution, to the 4x times. Yeah. And then those combine. Oh, yeah.
Yeah. Well, this one had a drink about. Wait, this is. Actually. I got it. It's not to do. I am saying, oh, you don't get a time to do it. Like, you guys see what it is. First students. Wait, are you supposed to do the two? Oh, okay. I see, I'll put the board. I think I got it. Dude, you gotta discover, right? The chin. See, whatever. Yeah. That's always good. What I'll leave with, yeah, 5, -5 minus 8. That's 3. Minus -5 minus 8. That's 3. That's 3x, is that?
Yeah,
And this brings in 6.
but that's the equal plus ones.
Yeah, yeah, equal plus 3, yeah. Yeah, it's like negative, yeah, and equal 3. That's the equal sign. But I got it. I think it. Equal P.
Let's see what you got, what y'all got. Sure. What did you end up taking?
A4.
Yeah, so to get the n, we need a -5 and a 2. What did you get in the front parts? 4x and x.
Yeah.
So surprisingly, it ends up being 4x and x. Really quick, let's do, because somebody else was asking about this too. Let's do the 2x. So again, I really want to get you guys comfortable with trial and error is, so it's not, you were right, it's 4x and x. But I want to get you guys comfortable with trial and error. To get comfortable with trial and error, you have to be okay. You have to be okay making choice. You gotta see it as part of the process. So maybe you made this choice. And that choice does give you 4x squared, and it does give you -10. Problem is the middle. That'll give you -10x, 4x, and what's -10x plus 4x? -6x, which just doesn't match the middle. Doesn't get it. But another way to get 4x squared is to do 4x times 4x, or times x, sorry. And if we do it this way, then -5 times x is -5x. 4x times 2 is 8x. And 8x minus 5x is 3x. That is bingo, that's what. So that would have been the correct factory. Somebody set up the equations and solved. Yeah, keep going. What'd you do for that? So again, the thing from here is that, again, what we're looking at is we're saying 4x minus 5 times x plus 2 equals 0. So you know that either the first level or the second level equals 0, and we don't know which one, so we have to assume both. So we set two equations up, 4x minus 5 equals 0. X plus 2 equals 0. And we solve. To solve this first one, how do you solve it? Adding 5. 4x 5. 5 by 4. You end up with x equals 5/4. And then somebody else already said it, but what about the second? -2, perfect. And draft those are just. Any questions, confusions there? Okay, good, really good start. So on Thursday, we'll come back and we'll look at problems and some factor, grouping, et cetera. See all. So. Good one.
I do, for tomorrow, I sent you an email.
Okay, well, hold on. Actually, one other thing, y'all, before you do, so for this week. Don't do the second homework, the one that says other equations, don't do that. We just aren't, we aren't gonna get to it, or we'll only get to a small part of it, so just don't do that homework.
Okay.
And then you said,
I sent an email for you. You said, no, wait, what?
for the, or wait, for what, sorry? So I mean, that's always the problem. I think you don't realize Tuesdays and Thursdays I teach from 9 to noon, and then I teach from 1:45 to 3, and then I have a meeting from 3 to 4. So 12 to 1:45 is my only time off, but that's also my lunch. That's why I was trying to get you to come in, but Monday, when you could come in, I teach. So my office hours are really only Monday and Wednesday from 9 to 11:30. That's when I'm open.
I do Monday to Wednesday somewhere. You just want to send me the times and then, like, minutes and everything.
Okay, and that's what I was looking at. I know you said one, but I was looking for you to give me all the available time that you had Monday, not just kind of like.
On Monday, I got from 9 to 10:30.
Okay, what, is it the same on Wednesday?
Monday was it, yes, sir.
Okay, so we'll do it tomorrow from 9 to 10:30. My office though is over at CHP 224. Yes.
HP 2.
CHP 224. Yeah, so we'll do that.
Okay.
Tomorrow. Okay. Sweet.
Thank you.
You're welcome.